I want to talk about 6 business cases which involves 30 fatal injuries in the construction industry. Statistics in the mobile phone usage states there are a lot of work from home users that faces issues. There are some users that face attention problems.
Equipany comes with a mobile app and a depth camera to identify the risks involved. Certain keywords are put into the app to integrate traceability. The reviews involved office assistant and user research. We also got reviews from data scientists and construction project manager. On average, the reviews were about 8.5.
Workplace fatalities is very high due to falls and falling materials. Hit by objects is also observed, and along with caught in between. What's shown here is a type of risk which is part of the risk matrix and the category of risk detected. Each case has a category of risk which maps to time taken. We scored the type of risk based on statistics to understand the impacts. AGS file format involving geotechnical information exchange was introduced in 1990. Here is a data table for soak-away tests of soil with a pit diameter. The category of risk is machine interpreted with incidents, potential risks, and issues. The operational metadata involving material purchase orders is used to create technical metadata involving IoTs to form a package structure.
IoT metadata management eliminates access to company shared directories and employee folders. Material minimization in site. An anomaly detected will be submitted to the event record and accessible via phones. The fifth business case. Construction activities through a camera and recording incidents through the Equipany mobile app. This is an example of monitoring construction activities on a small building project with an open space.
This is the 6th business case after the driver has informed there's an oil leakage in the construction site. Among these no AI in businesses, there are 73% of companies, at least one AI tech, there are 15%, and piloting AI 2%. Now the next is usage in percentage by the solutions. AI hardware is the least used with 5%, and other technology apart from the registered AI solutions, they are like 66%. The solutions are distributed in nature. So when you take AI adoption rate, there is ICT, which says the adoption rate is about 63%. But when it comes to construction, there's a drastic change. This is about 36 to 64. So let's move on to AI sectors. You have health, hospitality, IT and telecommunications, legal, retail, and undefined. So let's go on to productivity and why this is actually very key part of it. Because 1970-72 onwards and up till 2020, the market sector output per hour is increasing steadily. Let's consider the other scenario where from 1992 to 2003 onwards, there is a drastic reduction. Alright, let's talk about the synthetic data generation. Here is our repository on Jury-KlinterAI SaaS SQL code management. So this is IoT metadata.csv. We have generated synthetic data using mokuru.com. So here is the same repository which also does cost codes for the IoT. For the purpose of tracking objects within construction foundation sites such as piling rig and cranes, we have trained about 922 images inside RoboFlow, and the entire dataset consists about 14K plus images. Legal re-engineering. So in legal re-engineering, I would like to talk about observability by parts. So we actually propose the vision exchange format VXF through machine learning to improve privacy, to promote discoverability, and to provide secure data exchange. So here is the process entirely. The request broker sends a request to wireless driver, which does SNMP get inside the file system and returns back and does a handshake. And this sort of a process is polled a certain duration. Let's talk about the product. So
we focus on the event record, the database. The database, we focus on eventual consistency, and then we move on to private and secure data exchange by taking into consideration mission exchange format, and then we move on to object detection and anomaly detection using statistics and machine learning. Then we produce our equip any finalized prototype, which will then take into activity recognition of site work, and then we'll consider integrated database of purchase orders. Then we'll move on to the KlinterAI with the cloud solution. So we have formed the data architecture diagram. So we focus on the IoT metadata. So the metadata will be journalistic in nature, which will be connected to the time series token data. So time series will be polled on a certain duration, and then we connect that to activity codes or risk or incident information. So all of these are aggregated into an analysis or a queue, which will be delivered across here using SAS PLSQL. So here is our database in unnormalized form. So what it can do is calculate operational time along with cost codes, and it can perform material minimization. So it includes material purchase orders apart from the labor and contract purchase orders. Then these material purchase orders are connected to equipment or machinery ID, which is then connected to the EPC number or the IoT unique number. And after the metadata is complete, the SNMP token is listed on a whole basis.
Once screenshots are taken, the data is sent over to the databases within SAS Studio, where this conceptual database model, we have a general table, material, IoT, and SNMP, where it is all basic values are stored into the general table.
We are at the SAS App Factory Cloud, and we have the schema as well. And we can associate the schema through this menu bar, and the IoT metadata information is listed. Once we run the PLSQL command into our results, we get the results as tables. So these are IoT metadata information which we can integrate to an application. So we have built here a no-code application using App Factory Cloud of the SAS. So once we click on it, we get the live stream directly. So live stream is an object detection algorithm it runs. So once we capture the risk, we record that into a form. So here there is a machinery and soil detected, and we have issue ID, case name, and issue type like delays, issues, and repairs, and case category like a potential issue, risk, or environmental incident. Then trace back in time hours, so you could say 100 or 20 to 30 hours, and then entities or activities captured. So you can do a multi-select on these. So if you submit that information as issues recorded 15, 375 indicators traced back, then about 29 hours of unexpected delays. So in the back office part of it, actually you have the IoT devices populating, and the SNMP tokens are still populating. So this is a live stream. This will be keeping on adding.
The example shows a process of 5 different activities that an excavator is performing under. Each screenshot corresponding activity and other data is then sent over. In front of you, we have a heat map that shows the relationship between the risk or impact that incident has occurred and the likelihood. In the top left-hand corner, you see that there are values that are less than bottom right-hand corner.
Our crowdfunding sites and multi-tenant prototype site had a lot of visitors. We also show medium and hash node statistics here.